This video discusses how to graph quadratic functions in general form. A quadratic function is one that can be expressed by the equation f of x equals ax squared plus bx plus c, where a is not equal to 0. The graph of a quadratic function is called a parabola. There are some general observations we can make just by looking at the equation. Well, first we know that parabolas are symmetric with respect to their axis of symmetry, which is the vertical line that passes through the vertex. If the leading coefficient is positive, the parabola will open up. If the leading coefficient is negative, the parabola will open down. If the leading coefficient is greater than 1, the parabola will be skinny and narrow. If the leading coefficient is less than 1, a proper fraction, the parabola will be short and wide. The quadratic function f of x equals ax squared plus bx plus c is said to be in general form. To find the vertex of a quadratic function in general form, the vertex is negative b over 2a, comma f of negative b over 2a. So to do that, we start by finding the x value of the vertex. We use the formula x equals negative b over 2a. Once you have the x value, you plug that into the function to get the corresponding y value, and the vertex will be an ordered pair. Symmetry points are points on either side of the axis of symmetry equidistant from the axis of symmetry. A symmetry point can be found by reflecting a known point on the graph, I like to use the y-intercept, about the axis of symmetry. So to graph a quadratic function in general form, we're going to start by finding and plotting the vertex. We'll find and plot the x and y intercepts. We'll find and plot the symmetry point, and then connect our points to create our parabola. Given the function f of x equals 3x squared minus 12x plus 12, let's graph it by finding the vertex, the intercepts, the symmetry point, and then we'll state the domain and range in interval notation. Starting with the vertex, the x-coordinate of the vertex will be negative b divided by 2a. So that's negative 12 divided by 2 times 3. That's 12 divided by 6. The x-coordinate of the vertex is 2. To find the corresponding y value, we'll plug that back into the function. F of 2 equals 3 times 2 squared minus 12 times 2 plus 12. And we get a value of 0. So the y-coordinate of the vertex will be 0, making our vertex the ordered pair 2, 0. Next, we want to find our x-intercept. To find any x-intercept, we always let y be equal to 0 and then solve for x. You can solve this quadratic equation however you like. I like to factor. I'll start by factoring out a GCF of 3, leaving us with x squared minus 4x plus 4. That quadratic factors into x minus 2 times x minus 2. Setting each one of our factors containing a variable equal to 0, we get x to be equal to 2 twice. This means that we only have one x-intercept, the point 2, 0. To find a y-intercept, we always let x be equal to 0 and solve for y. When simplifying, we'll notice that both the terms containing a variable fall out since we're multiplying by 0, and we're left with y is equal to 12. So it's kind of a shortcut when we're in general form that the y-intercept is always 0, c. Let's plot these points, and then we'll use the axis of symmetry to get a symmetry point, and we can draw in our parabola. Notice that our vertex is also our y-intercept. Also our x-intercept, and then plotting our y-intercept. We only have 2 points. This is a case where we have to get an additional point in order to draw in our parabola. You always need at least the vertex and 1 point on either side of the vertex. Looking at our y-intercept and the axis of symmetry, we'll see that that y-intercept is 2 units to the left of the axis of symmetry. Therefore, there has to be another point right here, 2 units to the right of the axis of symmetry. This is our symmetry point, and it's the ordered pair 4, 12. Now we can draw in our parabola. We want to state the domain and range for this parabola. The domain will be all real numbers. This is true for any quadratic function. And our range, we see that our first y value coming in from the bottom includes 0 and then goes up to positive infinity. Let's try another one. We want to graph the same way. We'll find the vertex and the intercepts, the symmetry point, draw in our parabola. The x-coordinate of the vertex, negative b divided by 2a. So that's negative 8 over 2 times negative 1. The x-coordinate of our vertex is positive 4. To get the corresponding y value, we'll plug it back into our function. Simplifying this, we get the y value of the vertex to be 2. Therefore, our vertex is the ordered pair 4, 2. When finding our x-intercept, we always let y be equal to 0 and then solve for x. You can solve this quadratic equation however you like. I typically like to factor, however this one does not factor. Therefore, we will have to use the quadratic formula. X equals negative 8 plus or minus the square root of 8 squared minus 4 times negative 1 times negative 14 all over 2 times negative 1. Cleaning up underneath of our radical, we're going to get 64 minus 56. It's negative 8 plus or minus the square root of 8 over negative 2. We can simplify the square root of 8 to be 2 square root of 2. We want to simplify the fraction overall. I think the easiest way to do that is to split it up into 2 fractions. Negative 8 over negative 2 plus or minus 2 square roots of 2 over negative 2. So x will be equal to 4. Now here we have a plus or minus divided by a negative. A plus or minus divided by anything will always result in a plus or minus. Think about it. If you take the positive and divide it by a negative, you get a negative. If you take the negative from the plus or minus and divide it by a negative, you get a positive. So we're still left with that plus or negative. And just the square root of 2. We end up with 2 x-intercepts for plus the square root of 2 comma 0 and 4 minus the square root of 2 comma 0. To graph this, you're going to want to get a decimal approximation. When stating the intercepts, though, you want the exact answer. So our decimal approximation here will be 5.41 comma 0 and 2.59 comma 0. Now let's find our y-intercept. To find the y-intercept, we always let x be equal to 0 and solve for y. Remember, as I mentioned earlier, there is a shortcut that the y-intercept when we are in general form is always 0 comma c. So we get a y-intercept of 0, negative 14. Let's plot these points. Vertex of 4, 2. Using our decimal approximations for our x-intercepts. Just shy of 5.5 and a little bit more than 2.5. And lastly, our y-intercept of 0, negative 14. We'll use the axis of symmetry to get an additional point. It's nice to have the same number of points on the left and right side of your vertex. My y-intercept is 4 units to the left of the axis of symmetry, therefore there has to be another point 4 units to the right of the axis of symmetry. And we draw in our parabola. We want to state the domain and range. The domain of any parabola is always negative infinity to positive infinity, and our range this time, negative infinity to positive 2 including.